All right, so let's take a look here at question number 42 and 43. And as we've been doing, let's go ahead and rewrite the given expression. So we have x squared minus y squared plus 18y minus 81. All right, let's go ahead and run through those questions, those two questions. Number one, is there a GCF? No, I don't see one. So question number two tells us to ask how many terms are there in our polynomial. Well, we have 1, 2, 3, 4 terms, which if you're looking at the reference sheet or you remember from class or maybe the past lab, 4 terms indicates 99% of the time that you're going to factor this polynomial by grouping. But that's not the case here. This polynomial here is probably the most difficult polynomial to factor in all of your practice tests. Maybe aside from the word problems where those can get a little tricky too, this is the most difficult, in my opinion, of all of the questions 1 through 55, I think. And it's because there is a perfect square trinomial hidden inside this polynomial here. So the first thing that we're going to do is take a look at this trinomial, and it's only a trinomial now because I've gone ahead and put parentheses around these 3 terms. And the first thing we are going to want to do is factor out a negative. So we're going to pretend that the GCF here is a -1, which means we're going to factor out a -1. And when we do that, the sign of everything behind this negative is going to change. So here we had a negative y squared, well now it's positive y. Here we had a positive 18y, now it's negative 18y. Here we had a negative 81, now we're going to be positive 81. All right, now what this is going to enable us to do is factor this trinomial nicely. And you may not have done a lot of work with perfect square trinomials, but a perfect square trinomial happens when you take the coefficient of your square term. The square term here, in this case, the coefficient is 1. Well, what's the square root of 1? Well, the square root of 1 is 1. Now take the square root of your constant, this last term. So here we have 81. What's the square root of 81? Well, 9. Now multiply these two numbers together. So 1 times 9 equals 9. Oops, I wrote 8 but said 9. So 1 times 9 is 9. And now double this result. So 9 doubled, or 9 times 2, gives us 18. And when this occurs, when the result of the square root of your first coefficient here in front of the squared and your constant, whatever the result of that multiplication is doubled, when that equals this middle number here, you have a perfect square trinomial. And so we have a perfect square trinomial here, which means we can go ahead and factor this. So we have y squared minus, and now a perfect square trinomial factors into, well, y and y. And now we're looking for the factors of 81 that add to give us negative 18. Well, we just said, what's the square root of 81? Well, it's 9, right? So 9 and 9. And we want these numbers to add to give us negative 18. Well, minus and minus, right? Because negative 9 plus negative 9 gives us negative 18. So we know our signs are negative 9. And now that we have it in this form, we can go ahead and rewrite it one more time in a different form. So we have our x squared minus, and now we have the same factor, identical factor, but now we have 2 of them. So we can now say, instead of y minus 9, we can now just say y minus 9 squared. Right? So just what if these were 3's? 3 times 3 is 9, or we can say 3 squared is 9. So all we did is we took this factor and squared it. All right, well, now that it's written x squared minus some quantity squared, hopefully some alarm bells are going off and you're saying, oh, there's a square minus, or also known as a difference. another square. So this must be the difference of two squares. But it's not as straightforward as that because look, this term here, yes, it's a square, but we are squaring a set of parentheses, right? We're squaring some quantity. So let's go ahead and, like we've done in previous examples, let's use u substitution to represent this quantity y minus 9. That's a 9. And so now let's go ahead and rewrite our polynomial one more time. So we have x squared minus, and now we're saying let u represent y minus 9. So u squared. And now it's a little easier to see that we're dealing with the difference of perfect squares. So we can go ahead and create our two sets of empty parentheses. Well, we're dealing with an x, so we have an x and an x. We're dealing with a u, so we have a u and a u. And we know with the difference of perfect squares, we do plus and minus. And generally speaking, this is where we would end. This is where we would circle our final answer. But because we're dealing with u substitution, we have to go back and replace what u represents. So let's go ahead and do that. So now we have x plus, and now what does u represent? Y minus 9. And here in the second factor, we have x minus, replacing what u represents, so y minus 9. And now we're going to go ahead and simplify, rewrite this one more time. We're going to have x, and because this is a plus sign, a positive, that means the signs of what's inside this set of parentheses are not going to change. So we have plus y minus 9. And here in the second set of parentheses, our second factor, we have x, except now when we distribute this negative through, we're going to have negative times positive y is now minus y, and negative times negative 9 is now positive 9. And there we have the final answer for number 42. X plus y minus 9 times quantity x minus y plus 9. All right, so that was, like I said, I think this is probably the most difficult polynomial to factor, only because at first glance it looks like, because there are 4 terms, that this is going to be a factor by grouping. But you could try factoring this by grouping, but you'll see that you can't get your sets of parentheses to match. You may not even have anything in common that you can pull out. Even if you tried to rearrange this, you'll just find that it becomes impossible to factor unless you recognize that you're dealing with a perfect square trinomial. And once you factor out that negative, it becomes nice. It's set up relatively nicely for us to go ahead and use u substitution and do the difference of perfect squares. All right, let's go ahead and take a look here at 43, and I might have to erase this work here from 42 to give us some room, but we'll see what happens. Let's see, maybe I can move it all over. And before I do that, how about I'll go ahead and we'll erase this, and then we'll move this all over. All right, and I think that'll give us enough room. So we have 8x cubed plus y cubed. All right, so let's run through those sets of questions. Number 1, is there a GCF here? No, I don't see one. So question number 2 asks us, how many terms are we dealing with? Well, 1 and 2, and when we're dealing with 2 terms, that tells us we're either looking for the difference of perfect squares, or we're looking for the sum or difference of cubes. Well, we definitely know we're not dealing with the difference of perfect squares, because difference means minus, right? Subtraction, and here we have a plus. But another pretty evident clue that we're dealing with cubes is that the power that we're working with is 3 cubes. All right, so we're dealing with the sum of cubes. With the sum of cubes, I'm going to go ahead and set up the model that you should be using, or that I find easiest to work with, I'll say. You might have a professor that shows you a different method, and as long as you get to the same answer, then there are, again, many different ways to factor. So as soon as you recognize that you are dealing with a cube problem, the sum or difference of cubes, if you go ahead and set up this model of blank parentheses, you have about accomplished 50% of the problem, because if you can set up this little blank model here, this will help you to factor your sum or difference of cubes. And so what we're going to do is whatever sign was in the original expression, we're going to just bring down to this first line here. So we were dealing with a plus, so I'm going to go ahead and put a plus in between the first line of parentheses here. All right, so this first empty set of parentheses, we have to ask ourselves, what number and variable cubed is going to give me 8x cubed? Well, this cube and this cube are going to act as the same cube. So what we're asking really is, what number cubed gives me 8? Well, 2 cubed gives me 8. And now what variable cubed gives me x cubed? Well, x cubed gives me x cubed. All right, now we're going to fill in our second set of parentheses with the information from the second term here of our original polynomial. So what variable cubed gives me y cubed? Well, just y, right? Y cubed is y cubed. And excuse me, now if you can fill in this line of the model, then you really should be able to fill out this last line, which is the final answer, because this is the most difficult line to fill out, figuring out what you need to cube in order to get back to the original polynomial. To fill in this last line, all we're going to do is use information from this first line. So a cube breaks down into a binomial and a trinomial. And for the binomial, all we're going to do is whatever was in the first set of parentheses is just going to come down. The sign in between the sets of parentheses in the first line is going to come down. And then whatever was in this last set of parentheses is just going to come down. All right, so we had 2x plus y. And now to fill in the trinomial part of our answer, what we're going to do is, to fill in the first blank, what we're going to do is square the first term of the binomial. So what is 2x squared? Well, 2x times 2x, right? That's the same thing as saying 2x squared. Well, 2 times 2 gives us 4, and x times x gives us x squared. All right, well, now to fill in the middle term of our trinomial, what we're going to do is multiply our two terms from the binomial together. So we have 2x times y. Well, when we multiply these together, what do we get? Well, just 2xy. And now to fill in the last blank of our trinomial, all we're going to do is square the last term of the binomial. So what's y squared? Well, just y squared. All right, but you notice we are missing signs, aren't we? So we're missing the signs for our trinomial. And to fill in those signs, all you have to do is remember this little acronym, SOP, same, opposite, positive. Same, opposite, positive. And these refer to the signs that you're going to be using. Same refers to whatever was in the original polynomial, follows you down, follows you down. So same is taken care of. Then we get to the next sign position, which is going to be the opposite of whatever was in your binomial here. So what's the opposite of a plus? A minus. So there's the opposite. And then the last sign in our trinomial is always positive, so plus. And so our cube polynomial here, our final answer when it's factored is 2x plus y, 4x squared minus 2xy plus y squared. All right, so again, let me go ahead and run through this one more time really quickly. You want to go ahead and set up this model of blank or empty sets of parentheses. So blank, cubed, whatever sign your original polynomial had, go ahead and put in between. and then another set of blank parentheses with a cube. Then ask yourself, what do I have to cube to get back to my original polynomial? What do I have to cube to get back to the original polynomial? Whatever you put in this line is going to help you with your final answer. So again, a cube breaks down into a binomial, so 2 terms, and then a trinomial, 3 terms. For the binomial, the first term is whatever's inside this first set of parentheses. The sign comes down. And then the last part of the binomial is whatever's in the second set of parentheses. So now you have your binomial taken care of. To fill in your trinomial, all you're going to do is, for the first term of the trinomial, square the first term here in your binomial. For the middle term, all you're going to do is multiply these 2 terms together. So 2x times y gave us 2xy. And then to fill in the last term of your trinomial, square the last term of your binomial. So in this case, y squared, well, that's y squared. And now at this point, the only thing we were missing were the signs. And so we're going to use that SOP, same opposite positive, to help us remember what our signs are. So same says whatever the original was follows you down, and that follows you down. Then you're going to take the opposite of whatever followed you down. So in this case, a plus followed us down. So we took the opposite of plus, which was minus. And then the last sign in your trinomial is always, always, always positive. All right, and I think there might be 1 or 2 more of these, so I think they'll make more sense as we do them. But if this is the first time you've seen this method, go ahead and try to watch it again or watch the next couple examples. Just trying to take a look. It looks like we have 2 more cube examples, so I'll be using this method for those as well. And I think by the end you'll find that this is a pretty quick way to go ahead and factor your cubes. All right, so pretty difficult examples here, 42 and 43. And you'll notice that now that we're getting to the end of this practice test, you'll notice they're going to start getting a little harder, and that's a good thing, right? It's good to challenge ourselves. All right, let's go ahead and take a look at 44 and 45 in the next video. I'll see you there.